Hey there, classes. Welcome back. We're going to go through all the things that we've seen in the last couple of days in class, particularly today's notes, which I think are some of the most important in terms of going forward with evolution. And I think for today's class, I think there's a pitching wedge right here. This would be just about right, which will tie into our first point. Got the sweater on today. It's cold in here because of the 23.5-degree tilt of our axis on this Earth. It's making it cold in this classroom. Seems to be getting really cold. Remember, it's going to get cold and dark. And after the 21st of December this year, remember the days will get a little bit longer. So do look for that as we move towards the solstice. All right, so let's jump on in here. I've got a really bad picture of a turkey. Well, in this case, it's a really, really bad picture. It's a stylized turkey being looked at by a coyote. And why the golf club? Well, here you go. If you look at the notes from the other day, we were talking a tiny bit about right here in town, good old Pacifica P-Town here. If you go to the Terra Nova High School upper field, now way back when I was in high school at Cappuccino across the hill, I remember coming down to Terra Nova, and that field used to be maintained as a soccer field. Now it's kind of laying fallow out there. A lot of gophers out there, a lot of moles, a lot of gophers, a lot of rabbits, and a lot of coyote. There's a couple of very large coyote out there. Some that I suspect may possibly have been coy wolf. They were really big. And when you look at the coyote out there, and if you've been to the back of the valley, you may have noticed that there's also a few wild turkey walking around. Now, wild turkeys, when you're looking at the skinny wild turkeys that run around, they actually are pretty good at evading predators because they can fly up into trees. They're actually pretty quick when they need to be. But when you look at what we just did for Thanksgiving, I think on our trivia question here in school, they said something like 38 million turkeys were used on Thanksgiving dinners around America. The turkeys that you saw on the table, literally some of them are called butterball turkeys, are so big you would never see them in nature. And the reasons are obvious. You would never see a turkey that big that really, and I know we started talking about sexual reproduction this month, but these turkeys can't even reproduce on their own. If a coyote, if a wolf saw something like that out there, say, it would go for that. That's a huge butterball. It's going to hit that one. I was out there with my son practicing, just swinging a golf club the other day, and on the upper field in Terra Nova, saw 3 coyote, which was very, very awesome. So do look for them. They're around town. They don't bother people at all. They're just looking for gophers, moles, and the occasional turkey to come on by that they can have for dinner. That is a great example of artificial selection. People have made turkeys that big by artificially selecting which turkeys will pass on their genes, which will get into the heart of what we're going to see today with this gentleman down here, Carl Sagan. He's an 8-minute clip. If you want to see it for yourself, I'll link it down in the notes, but also look for it yourself on YouTube. It's easy to find. It's an 8-minute clip. Look for the slightly longer one. Hey Crabs, Carl Sagan. Carl Sagan was one of my very, very favorite scientists as a kid growing up. He passed away, unfortunately, a couple of years ago, but he's got a story about some crab that were artificially selected to slightly look like a person. So we'll see that in just a second when we get to today's notes. And then finally, the other day we talked a little bit. Again, that clip was only about 10 minutes. I love using these little clips because you can talk about the good science and the things that's not so good. A tiny clip from Mr. DNA, if you saw that in the 1993 movie Jurassic Park. The 1993 Jurassic Park movie was the one where all the people are stuck on an island and they get, eaten by dinosaurs, as opposed to the other movies where there's a bunch of dinosaurs that were eating people that were stuck on an island. Wait a second. All the movies are like the same. Anyway, in the 1993 movie, they had a great scene where it shows how they supposedly cloned dinosaurs. Hated to burst everyone's bubble, but we have not been able to find any viable, even close to the amount of DNA it would take to copy a dinosaur. The amount of DNA that you find, we used across the room here an analogy of the encyclopedias. Encyclopedias that I have in my class right here have 32 volumes in them, and it would be a little bit like trying to put together an encyclopedia volume if you only had, say, 16 of them. You only had half as many volumes as needed. And you said, well, to fill in the rest of the volumes, we couldn't find the rest of the encyclopedias, so we just used some random books. In the movie, in the Jurassic Park movie, they supposedly fill in the rest of the DNA that they couldn't find with frog DNA. Again, not possible to put in that much of a missing genome because it's just far too much information to try and gather. Even the other example we used of the La Brea tar pits right here in California. We'll spend a little bit more time talking about the La Brea tar pits again next week. but the La Brea tar pits have the actual bones. When you look at a dinosaur fossil or a dinosaur bone, like you go to the California Academy of Sciences up there, you're not really looking at the bones of the dinosaur. You're looking at a rock and the shape of the bones. All the bone material has been replaced by minerals. When you're looking instead at the bones that you see at the La Brea tar pits, that's pretty cool. Those are animals that were actually caught in the petroleum down near LA, and over the years when they get buried and we pull their bones out of the pits, we actually have the bones. And again, even those bones, even a few thousand years old, we really don't have any viable DNA that we can clone or copy from there. There is some hope that we could perhaps get some DNA from some frozen mammoths that they found up north. But again, just a few thousand years ago, there's just too much information lost. So some of the cool genetic stuff that we've been checking out the last couple of days in here, let me turn this off for just a second. Getting to the first part of the notes. This was in our advisory today, but I wanted to kind of point it out to all the classes, and this is good for everyone to think about stress. They had a good advisory today on how to handle stress. Remember, a little bit of stress is a good thing. You wouldn't want to just have completely a no-stress life. You're just sitting on a beach all the time in Hawaii, turning into actually, it doesn't sound too bad about now. But the point is, a little bit of stress is a good thing. It motivates you. Used a Zen quote, which is, it's a little bit like tuning an instrument. You don't want it too loose. You don't want it too tight. You want it just right. In terms of the stress response, that's a good way of thinking about it. A little bit of stress can be motivating. One of the great things they did with advisory today was talk a little bit about how to manage your stress and the things that you have to do. For example, in this class right here, we talked about evolution hasn't really prepared us for being in a class taking notes all day. So we try and make sure we change it up quite a bit and we move things around as much as possible, because sitting there, evolutionarily speaking, is not something that when we evolved on the savanna of Africa has really prepared us well to be sitting in class taking notes all day. So we kind of work with that a little bit. Moving on, remember, it's all about this word. This was the word of the day, selection. The other word of the day was variety, but today it was all about selection. And in terms of the Carl Sagan picture that you saw earlier, I'm going to pull up the last slide that was up here today. I spin the boards over here. And I did a really, really bad picture of the carapace, or the shell, everyone just calls it the shell, of a crab. And I'll move my camera just a little bit so you can see it hopefully a little bit better. But a carapace, or the shell of a crab, has a pattern on it that is inherited. It's been passed down through the genes, through the chromosomes, from parent to child. And while the patterns might look random sometimes, occasionally, a crab had come along in this one particular area of Japan where there had been a samurai battle back around the 11th century that by chance looked a little bit like a human face. If you know the story, they're called the Heike crab. When people saw this, when the people who were fishing saw these crab, when they pulled them out, instead of taking them to market to sell them, to cook them up, to eat them at home, they would instead toss them back. The act of tossing them back is what we call selection. It goes along with this sheet right here that the students should have in their notebooks today. That's artificial selection because humans were doing it. We call it artificial when humans do it. We call it natural selection when something, for example, like the environment gets colder, gets warmer, when the environment puts on selective pressure. It is important also to remember that when we're talking about selection, sometimes that word can have a lot of connotations to it. This book right here, the most amazing and important book that really is the basis for all our biology, The Origin of Species, Charles Darwin. Sometimes it has to be pointed out because it'll come up in this class when we mention the Scopes trial later on. Some people have tried to use survival of the fittest selection in social terms. That's unfortunate because it's not meant for social terms. For example, during the early days, there's lots of examples you could use, of the Industrial Revolution, some people were making absolutely unbelievable amounts of money, while some people were working in factories. We talked a little bit, 2 weeks ago about Upton Sinclair, the jungle, were working incredible hours, 14, 15 hours a day, sometimes in ridiculously bad conditions in factories. People would try and justify that sometimes by saying, well, it's survival of the fittest. The people at the top were meant to be at the top while the factory workers were meant to be doing that sort of thing because that's what they were most fit for. Again, not at all what survival of the fittest is about. In the case of selection, in the case of Darwin, what they're talking about with selection is simply which ones are able to pass on their genes. In the case of the crab, in the case of the Heike crab, the ones that were selected by the fishermen, not really meaning to select for a face, sort of accidentally, but it was still artificial because people did it. Artificially selected crabs that could pass on their genes, and eventually you had quite a number of crabs in this one bay in Japan that looked particularly like a samurai warrior. A very, very cool story. I encourage you to check it out. And again, you can find the 8-minute clip on YouTube, and I'll link it down below. By selecting for survival, we're talking about the ones that are most able, most by chance, by odds, able to pass on their genes. That's why at the very, very beginning of this year, we were doing a little bit with probability and statistics. That'll come in again, especially when we hit Punnett squares and how we do things like how did you get your eye color or your ears attached or unattached, that sort of thing. Finally, just a word about this book. You got to realize that when Darwin put all these ideas together, he did it completely from his observation skills on the HMS Beagle. Didn't know anything that we've checked out in here over the last 4 or 5 weeks. Nothing about DNA, protein sequencing, how ribosomes make the proteins using RNA instructions from the DNA. Nothing about eukaryotic or prokaryotic cells. Stunningly amazing when you really think about the theory of evolution, the ideas of evolution, all put together in undoubtedly one of the most important science books in history. So please check out for yourself The Origin of Species, and also, again, one last time, putting in a plug for good old Carl Sagan. Have yourself a great day. We'll see you online. Look for the online quiz this week, and I'll see you back here in class. Bye-bye.